Today's lesson's on transformation of the square root function. Here you see the standard form. We want to see how A, B, C, and D affect the parent graph. First thing we need to do is graph the parent graph. And here's the parent graph. Notice here we have a +2 and a -2 outside the square root. Notice that that's in the place of D, so let's see how D affects the graph. So I'm going to graph +2. What do you notice? We have the same graph as the parent, except we've shifted it up 2 units. So we're going to call this a vertical shift up 2 units. Now let's look and see what subtraction would do. Now we see that it's the same as the parent graph, except it's shifted down 2 units. So we would call this a vertical shift down 2 units. So what does D do? It's a vertical shift up or down. Up when D is positive, down when D is negative. Now let's look. We're going to put the plus or minus inside the square root. This is C. So let's go back to our calculator. Let's see what it does here. I'm going to do the +2 first. Now graph that. There's the parent graph. Here comes the next graph. Look, it shifted left 2 units. So we have a horizontal shift left 2 units. Now let's go do the subtraction. And what do we think is going to do it there? We have a shift right 2 units. So we would call this a horizontal shift right 2 units. So let's summarize this. We have a horizontal, C affects it horizontal shift left or right. Left when C is positive, right when C is negative. Now let's do B. Let's see how B affects the graph. So I got B is 2 in the first one. B is 5 in the second one. So square root 2x graph. There's the parent graph. What do you notice about the red one? It got further away from the x-axis. So we call this a stretch. And we're going to see it's a stretch by a factor of 2. Now let's see what 5 does. So we have a B of 5. And it looks like it got stretched even more. We would call this a horizontal stretch by a factor of 5. So what do you notice? As B gets bigger and bigger, the graph is stretched more and more. Now let's look at a B being a number between 0 and 1. First number I'm going to choose is 0.5. I'm going to graph that. Here's the parent. Here comes the next graph. What do you notice? It got closer to the x-axis, so we're going to call that a shrink. So we're going to say we have a shrink by a factor of 0.5. Now I'm going to choose 0.2. 0.2 is smaller than 0.5, so what do we think is going to happen? Oh, it got closer to the x-axis again, so it shrunk even more. So here we have a shrink by a factor of 0.2. So as you notice, the numbers as they get smaller and smaller or closer to 0, we get more of a shrink. It shrinks even more and more. Now let's look at B being negative. What do we think is going to happen here when B is negative? Here's the parent. Oh, what did it do? It reflected over the y-axis. So we would say we have a reflection over the y-axis. So B, we got a stretch when B is greater than 0, shrink when B is between 0 and 1, and reflection over the y-axis when B is negative. Now let's look at A. First thing is I'm going to make A 2, and then I'm going to have A as 5. How do we know the difference between A and B? A is outside my parenthesis, outside my square root. B is inside. What do we notice here? There's the parent. Oh, we stretched it. Now, is there any difference between an A stretch and a B stretch? Look like A stretched a little bit more than B. Let's go back in and I'll put square root of 2x in. And yes, A stretches the graph more than B does. Now let's have an A of 5. What do you think is going to happen to my graph? Is it going to affect it the same way it does in B? There's my second one. That's 2 times the square root of x. There's 5 times the square root of x, and it's stretched even more. So it does do the same way. So as A gets larger and larger, we have more of a stretch. So here in the red graph, we have a stretch by a factor of 2. And in the black one, we have a stretch by a factor of 5. Now let's pick numbers, an A value between 0 and 1. Do we think that this is going to be the same as B? 0.5 times the square root of x. Is it going to shrink like B did? Yes, it did. What did we notice? It shrank even more than the B one when we did 0.5x. Now let's do 0.2, a smaller x. What do we think is going to happen here? Is it going to be the same as B? Will it shrink even more? That's what happened when B got smaller. And look at that. It got almost so small that we couldn't see it. It looked like it was the x-axis. So if we have a number between 0 and 1, we have a shrink. Now what we want to do is see what a negative A does. Do we think it's going to be the same as B? B, we had a reflection over the y-axis. Is this going to be a reflection over the y-axis, or is it going to be something else? There's my parent, and there's my reflection. It didn't reflect over the y-axis this time. It reflected over the x-axis. So let's summarize what A does. A is a stretch when A is greater than 1, shrink when between 0 and 1, and a reflection over the x-axis when A is negative. Here's a couple problems for you to try. Describe the transformation and graph these.